We're live. Boa noite, pessoal. Tudo bem? Good evening, folks. Welcome to the primeiro colóquio internacional de pesquisa em filosofia da UFSC. It's good to have you here. Thank you so much for joining us. I'm very excited to introduce you to Professor Cailin O'Connor, who will be our speaker for this evening. Professor O'Connor is Associate Professor in the Department of Logic and Philosophy of Science and a member of the Institute for Mathematical Behavioral Science at UC Irvine. She's the co-author of the book, The Misinformation Age, which I think certainly is one of the most significant epistemological accounts about the threats posed by misinformation in the current political climate. And I have to say that I love that Professor O'Connor shares a review about her book, which reads as follows. It read like a mediocre college paper, but provided less impact. I think we can all tell who this reviewer voted for, right? Professor O'Connor is also the author of the books The Origins of Unfairness, Social Categories and Cultural Evolution, published last year by Oxford, and Games in the Philosophy of Biology, published this year by Cambridge University Press. So I should also mention that Professor O'Connor described herself as a poultry enthusiast, poultry, not poetry, poultry, and aerial acrobat. So let's welcome Professor Cailin.
Well, thank you for having me. I'm really honored to be speaking to this group. I actually just the last week, 2 of my new chickens started laying, so I am super pumped about that. My poultry enthusiasm is going really well right now. Okay, Gustavo, I'm ready to share the screen. Good, and we can start the talk. So the title of the talk I'm giving today is called Measuring Conventionality. It pulls on a theme from this book that Jerzy mentioned, The Origins of Unfairness. And I will just get started. So this talk is about conventionality. Let me start with a couple examples of conventions in different societies. So in some countries, people drive on the right side of the road. In other countries like India and Australia, people drive on the left side of the road. So these are 2 examples of different conventions in these countries. In many different cultures, there are different conventions for greeting. So in some countries, you shake hands. In other countries, you bow. In some countries, you kiss on the cheek. When I'm in Europe, I never know how many I'm going to have to do. Is it 1 or 2 or 3? I don't know. Briefly in March, I went to a conference where the convention was elbow bumping to avoid spreading COVID. Here's one more example of a kind of convention. In many different countries, there are different conventions for gender division of labor. So in southern India, making rope is typically considered a women's job, whereas in Slovenia, it's considered a men's job. All right, so we have these different conventions, but what is a convention? Well, philosophers have argued about this for a long time, but there are a few things that people generally agree about. Conventions are usually thought to involve stable, maybe beneficial patterns of social behavior. And what defines something as a convention is that these behaviors are arbitrary in the sense that they could have been otherwise. They're solving some problem in one way, but there could have been some other solution. So now I can say what the kind of big picture aim of this talk is going to be. So what I'm going to do is argue for a conception of conventions as coming in degrees of arbitrariness. So when philosophers have defined conventions before, they've usually given definitions that divide things into conventions and non-conventions. Here's what a convention is. Here's what is not a convention. But I think this is the wrong picture. And instead, we should really have a scale giving us degrees of conventionality. And then second, I'm going to give a measure of this arbitrariness, a way to put a number on how arbitrary different conventions are. And part of the aim here is to improve cultural evolutionary explanation. So under this conception or framework, when we're talking about cultural traits and why we have them, well, we shouldn't explain them either as functional or arbitrary, but always as both, possibly to different degrees. And also, as I hope will become clear, the measure can provide a kind of framework for debating and discussing just how arbitrary different conventions are and comparing conventions across different realms. All right, so here's a roadmap for the rest of the talk. So first, I'll introduce some philosophical accounts of convention, in particular, focusing on those few ones that do treat conventions as kind of coming in degrees or on a scale. In part 2, I'll talk about evolutionary models of cultural traits, and that will set us up for the rest of the talk. In part 3, I'll describe the measure of arbitrariness or how conventional things are. And then in part 4, if there's time, I'll give either one or two examples applying the measure to actual cases of the emergence of conventions. All right, so with that, on to part 1. So I take David Lewis's account of convention to still be the received view. It's still the one most philosophers respond to or start off with when they're talking about convention. So in his 1970 book, he describes conventions as a sort of equilibrium in a coordination game. So this is also going to be a really useful account for me because I'm going to use game theory and models throughout the talk to kind of build the framework I'd like to. And Lewis was really the first person to do that. So a coordination game is a representation of a kind of cultural scenario where people want to coordinate their behavior, but there are multiple ways to do it. So here's a little representation of one of these games. This is the most simple kind of coordination game and the one really that Lewis depended on a lot in his account. So you have two players, player 1 and player 2, or two individuals involved. And then they have two strategies or two things they can do. So here, player 1 can pick A or B, player 2 can pick A or B. And then listed here are the payoffs that they get for some combination of strategies, where player 1 is listed first, but here they get the same payoffs for whatever they do. And in this scenario, we can see that if they pick the same thing, they both pick A or they both pick B, they get a payoff of 1, so they get some good payoff. But if they don't coordinate, they pick two different things, then they get a payoff of 0. So what they want to do is pick one of these two things. They don't really care which, but they want to coordinate. So this could represent something like the driving scenario that I started the talk off with. A could be driving on the right-hand side of the road. B could be driving on the left-hand side of the road. And you care much more that you drive on the same side of the road than that you go one way or the other. So Lewis had a sort of complicated definition of what a convention was based on this. But the approximate idea is that you have a group of people, they all adhere to one of these equilibria. They expect everyone else to adhere to the equilibria. And they prefer to do so if the others do so as well. So that was his kind of account. A lot of people presented various challenges to him. One person who really came at him was Margaret Gilbert. And I want to mention one of her challenges, and you'll see why this is sort of relevant to the talk here in a minute. So she pointed out that there are games which will fall under Lewis's definition of convention, but where the conventionality of the conventions seems attenuated. So here again is this same kind of game, but suppose one of these equilibria is much better than the other. So let's let x equal 100 here. So the B equilibrium just gets a much higher payoff. Well, what Gilbert said is, suppose you have a culture and they're all at this B equilibrium. You don't really think of it as a convention so much because there's some reason that they're there. You explain it by saying, well, they do that because it gets them much better payoffs rather than they're just finding a way to coordinate. Now, Lewis actually had a response to Gilbert. So what he would have said is, in a case like this, the A equilibrium is a deficient equilibrium. And so this isn't really a case where you see conventions because you can't get everyone expecting each other to play the A equilibrium because it's so bad. But that response doesn't really seem adequate to me because you can have a whole range of scenarios. You could imagine X being 1, so that's Lewis's core case. It could be 100, but it could also be sort of anywhere in between. And it seems weird to pick a spot where you say, well, now we have a scenario where we have conventions versus a scenario where we don't. Instead, maybe you'd want to say there's a whole range of cases here, from those where there's a lot of arbitrariness in the conventions, like the Lewis cases, and there's not very much arbitrariness like the Gilbert cases, but we'd want to scale between them. Now, Ruth Millikan has also talked a lot about convention. She's really been focused on linguistic examples and semantic meaning. And thinking about these examples, she gives a definition which includes a requirement that conventions should be unlikely to emerge a second time. So if you kind of roll back the cultural evolutionary tape and start again, you shouldn't come up with the same pattern in a convention. But notice that that requirement eliminates the kind of cases that are totally core cases for Lewis. Because if we think about, say, driving on the right and left side of the road, if we rolled back the tape and start again, well, absent other factors, you might think there's a 50-50 shot that you'd get the same convention again, which is actually quite a high likelihood. Now, if we look at a linguistic case, that does fit what Millikan's talking about. You know, if we tried to evolve a term for glasses again, it's probably not going to be the word glasses. So again, we might want to be able to think about scaling between cases where there are really only a few options and they're quite likely to emerge if we did it again, in cases where there maybe are even an indefinite number of options, a whole lot of possible equilibria that we might end up at as we evolve conventions. So, motivated in part by examples like this, a very small number of philosophers have advocated for thinking of conventions as coming in degrees of arbitrariness, or people use the term naturalness. Now, these accounts have focused on linguistic implicature and especially indirect requests, and whether implicature is in part conventional or if it just follows inferentially from the rules of conversation and thus is not a convention but is a sort of inference. So that I talk a little bit more about in the paper that this talk is based off of, but I won't talk too much about here. I will talk, though, about one paper by Mandy Simons and Kevin Zollman, who, focusing on linguistic implicature, give 3 senses in which some convention could be more or less natural or arbitrary. So their 3 senses are: 1, well, some conventions are better than others from a payoff standpoint. 2, some conventions are more likely to emerge than other conventions are. 3, some conventions are more stable than others. If they emerge, they're unlikely to be abandoned. So this first sense is the kind of thing that Gilbert was talking about, where you have a B equilibrium that has a really good payoff. And maybe that would be a sense in which a convention is more natural. These second 2 senses, to talk about what Simons and Zollman mean there, we want to switch to a cultural evolutionary framework, and that will also be useful for the rest of the talk. So with that, let's move on to part 2, evolutionary models of cultural traits. All right, so when people are thinking about cultural evolution and the emergence of patterns of behavior, and they're modeling that, there's some things that these models pretty much always involve. So you're usually looking at a model where you have a population of individuals, these would be people in a group, that have different possible variants or strategies. They're doing different things. So this could be the left and the right-hand side of the road, or shaking hands versus elbow bumping. Then you have some repeated interactions over time. So you have cultural interactions in this kind of scenario where you're taking these behaviors. And then the models have rules for change. These are usually called dynamics that stipulate how these variants are going to change over time based on these interactions. And then typically what you see in these models is that over time you have cultural change, and then they end up at equilibria. And these are going to be stable, maybe beneficial states that typically could have been otherwise. So in other words, cultural evolutionary models often can successfully represent the cultural emergence of conventions. And so we can use them to talk about these kind of these frameworks for conventionality as coming in degrees. Now to do that, I want to introduce just one example. So the replicator dynamics is one dynamics or set of rules for cultural learning. It's probably the most widely used dynamics in evolutionary game theory. And it specifies that if you have some invariant in a population, it will increase or decrease in prevalence proportional to the payoff it receives. So if you're doing something that's very successful, it tends to become more prevalent in a population. If it's not very successful, it gets low payoffs, it tends to die out. So this is just one kind of dynamics. So let's say we have a population playing this game, the Lewis coordination game, and evolving according to these dynamics. What would happen? We can represent the behavior of this model using these little lines that are called phase diagrams. So here we have a model where x equals 1. You have two equally good possible conventions or equilibria. And what this line represents, sorry, where did my cursor go, is all the states the population could be in, from everybody playing B, everyone driving on the right side of the road, to everyone playing A, everyone driving on the left side of the road. And then the arrows show us how the population evolves. And what we see here is that whenever there are more Bs, you tend to move towards having even more Bs toward the B equilibria. When there are more As, you tend to move towards having even more As, the A equilibrium. This makes sense in a coordination scenario. If you're doing the more prevalent variant, you tend to coordinate more often, you get better payoffs, and then maybe that expands. Here is a representation of the model where x equals 50. So you have one equilibrium that's way better. And we can see the qualitative behavior is kind of similar. Things move towards B when there's more Bs and A when there's more As. But in this case, even just a few Bs in the population is enough to get it evolving towards all B. And that's because this gets a lot better payoffs. And so even if you're coordinating just sometimes, but you're getting this great payoff, it's going to tend to be more successful. Now we can define for these models what are called basins of attraction. And what a basin of attraction is the number of states, sort of the area in this phase diagram that goes toward one equilibrium. And in this case, we see that we have two and they're equal sized. So we might say, knowing nothing else about a population, it's sort of equally likely that it would evolve towards either one of these equilibria, equally likely that you'd end up driving on the right or the left side of the road. In this model, we have basins of attraction of very different sizes because this equilibrium gets higher payoffs. So now we can say what these sort of second and third senses of naturalness for Simons and Zollman are. The B equilibrium here has a greater likelihood of emergence. There are more situations that are going to end up heading toward that equilibrium. We can also say here what it means to say an equilibrium is more stable. So here, if you're at the A equilibrium, a little shock or experimentation or changing of behaviors is going to kind of move you enough that suddenly you're going to be evolving towards B. Whereas if you're at the B equilibrium, if people make some errors or try some different behaviors, you're just going to evolve right back to B. So we can see what it means to have one equilibrium be much more stable than another. Okay. So I'll just note quickly that in this example, the sort of three senses of naturalness for Simons and Zollman all line up. So the payoff of a variant might be higher, and that would also mean it's more likely to emerge and that it's more stable. It all goes hand in hand. And this will often be the case in this kind of model, though you can come up with examples to make those come apart, but that's kind of outside the scope of this talk. So we just won't worry about those examples. All right, so now we've got the kind of setup here, what a cultural evolutionary model looks like, why we care about them. So now what I'll do is introduce the measure of conventionality. So I'm focusing on the arbitrariness of conventions and thinking of this arbitrariness as coming in degrees. And when I say arbitrariness here, I'm really thinking about this notion that a convention could have been otherwise. The arbitrariness tracks to what degree could a convention really have been otherwise? And for that reason, I'm going to focus on naturalness 2 from Simons and Zolman, the likelihood of emergence. So I was sort of developing this project around the same time they were writing their paper and had only focused on this one sense. But I think it really is the one that tracks the kind of arbitrariness that I'm talking about here, and that people usually tend to be talking about when they're focusing on conventions. So the measure is going to draw on information theory. So this is the theory which addresses questions related to the transfer of information. Your first thought might be, what is the connection? Why does that make sense? Well, we have this scenario where you can have different equilibria that have different probabilities of emerging, or in our example, basins of attraction. What these probabilities do is determine how much we learn or how much information we gain when we see what evolved in a cultural scenario. And that amount of information is the measure of how arbitrary these conventions are. And in particular, the measure I use here is what's called Shannon entropy. So in information theory, entropy measures for some information channel how much information on average will come through it. And a channel just means some variable that could be in different states. So you could be talking about the telephone, and the different states you could be in are different words that are being said. Or you could be talking about a traffic light, and the different states are red, yellow, or green. And so you want to ask, for this channel, the traffic light maybe, when I look at it, on average, how much new information do I get? And that's what entropy measures. And it's basically a weighted average. So entropy, you say, here's all the different messages that I could get through this channel. I'm going to do a sum over all of these of how likely they are. So how likely is it that I'll see this message times the amount of information that message contains. So you just do this weighted average. Of course, the question then is, well, how much information does that message contain? And the answer is that the amount of information in a message depends on how likely it is. And in particular, the way it's usually measured is as the negative log of its probability. And you might be thinking at this point, like, why would that make sense? Why would that be the thing that tells you how much information is in something? I promise there are good reasons for it. I'm not going to go through them, but I am going to give a kind of intuitive sense of why this is a good measure of how much information is in a message you receive. So here's the negative log function. So when x equals 1, information is 0. So basically, if a message is completely certain, you get it 100% of the time, it doesn't contain any information. And this should make sense. So imagine a stoplight that's always red. If you look at that stoplight, you don't learn anything. It's always red. You knew it was going to be red. You looked at it. It was red. There's no information there. Then the less probable a message is, the more information it contains, the more it can surprise you, the more you can learn by hearing it. And that again should be kind of intuitive or make sense. So if I said to you, a moose just walked into my room, that would be a message that should contain a lot of information. It should really surprise you. Versus if I said a cat just walked into my room, that should be a message that contains less information because it's just a more probable thing to happen. All right. So let's just give a little toy example to see how this works. Suppose we have a fair coin flip and our informational channel reports the outcomes. So we have two possible messages, heads or tails. They're equiprobable, so the probability of one is 50% and the other is 50%. Now, if we calculate the entropy of this channel, we say, okay, half the time we get heads and that has this much information. Half the time we get tails, it has this much information. On average, the amount of information is 1. So this has what's called 1 bit of information. If we had a very biased coin that comes up heads 99% of the time and tails 1% of the time, we can do the same calculation and the entropy is going to be 0.08, so it's much lower. Now, the reason here is that we learn less when we see this coin flip. So when it comes up tails, we learn quite a lot because that's surprising. But most of the time we expect it's going to come up heads, and then it does come up heads and we learn almost nothing. All right. So in general, holding other aspects fixed, when we have a channel, the entropy will be higher when the messages are closer to equiprobable. So that's what this is supposed to represent, or where there are more messages. And maybe you're starting to get the picture now, because one of these tracks the kind of Gilbert example I started with, and one of the tracks the kind of Millikan example I started with. So let's connect it all up now. We can use entropy to measure how surprising it is on average, or how much we learn when we observe a convention in a society. So here, the messages are the conventional outcomes that have these different probabilities of emerging. And then we can say the higher the entropy, the more arbitrary some arena is, the greater the sense in which things really could have been otherwise. And this allows us to track both the kind of things that Gilbert was worried about, where there are differences in payoffs between different outcomes, and they have different likelihoods to emerge for that reason. And also the kind of thing that we noted with Millikan, where sometimes you have really a lot of things that could happen in a cultural evolutionary scenario, and other cases you don't have that much that could happen. All right. So that's the big picture. If we return to this example, we can calculate entropy here and sort of see that it kind of fits our picture. So here the entropy would be 1, just like that unbiased coin flip. Here it would be 0.13. So in this case, there really is a stronger sense in which things could have been otherwise than in this latter case when there's a really good convention and people kind of evolve to it for that reason. Now I want to flag, I've made a little flip from what previous philosophers were doing when they talked about like natural conventions. So Simons and Zolman, for example, were saying that some conventions themselves are highly natural. What I'm talking about now is a kind of arena for evolution. We can look at a whole arena and say, how much arbitrariness is there in the evolution here versus how constrained that evolution might be. But you actually can use the same measure to talk about individual conventions. So an individual convention that gives you very little information, you'd say, well, that's quite a natural convention. We expected it to emerge. If it gives you a lot of information, maybe less natural. Okay. So to pull out a kind of consequence here, when we apply this measure, we see there's only one value, 0, where traits aren't conventional at all. They're not arbitrary at all. And these are the cases where you have just one outcome that's guaranteed to emerge. And then for all the other values, there's some chance things could have been otherwise. And furthermore, there isn't an end to the measure. Conventions can be arbitrarily arbitrary. And I think sort of putting this out there pushes against these accounts that work to separate conventions from non-conventions. And we can see, well, that's not really the important thing to do. Instead, we should be focusing on the diversity within this category of convention, where we have many, many different types of conventions, but we can kind of distinguish between them and how arbitrary they are, how much they really could have been otherwise. This also, I think, can inform how we explain cultural traits. We generally shouldn't appeal only to functionality when explaining traits, and we shouldn't appeal only to chance historical factors and coordination. Instead, most traits are somewhere on a scale of conventionality. It's partially to solve coordination problems, and then maybe also there are some reasons why we picked the particular solutions we did. All right, so I'll give an example or two. Yes, there should be time for that. But before that, what I want to do is just go through 3 possible challenges or problems with this account that you might bring up. So here's the first challenge. Just these models. So I gave this very particular kind of example of a cultural evolutionary model, and I use sort of game theory and evolutionary game theory here. But the account is by no means limited to this sort of example. So you can apply this measure to any probabilistic representation of the emergence of conventions. And there are different ways to get that kind of representation. So there's lots of different types of cultural evolutionary models. Some of them have infinite populations. Some of them have real randomness built into them. Some of them incorporate information about starting points and constraints, so might incorporate information about a real culture in building the model. You also can use real data in this measure. So for example, you can look at a cross-cultural data set and ask, how often have different types of conventions emerged across real cultures? And from that, get an outcome. Or you could run lab experiments where you have small groups of people develop patterns of behavior and ask, well, how often do they develop these different patterns? And again, that's another kind of set of probabilities for different conventions that you could use in this measure. Okay, challenge 2, representation dependence. So if we're looking at any real case where conventions have emerged or even could emerge, we can represent these probabilities in many different ways. We can never just sit down and observe real probabilities in the world, even if we gather data cross-culturally. I mean, we have to make a lot of choices about how we gather that data. And then there are a lot of questions about, well, did these cultures influence each other? Are we really capturing the kind of probabilities we wanted to? So that's a kind of issue. And then there's a slightly different but related issue, which is that when we look at the same cultural evolutionary scenarios, we might want to be measuring or thinking about different things related to them. So we might want to be thinking about how arbitrary is this convention absent any context? Or we might want to ask, how arbitrary is it that we get this convention given some set of historical or cultural influences on a culture? Those are both questions we might want to look at, and they would, require really different models or representations to look at, but we'd still be talking about the same convention, right? So there's no total real answer here. The only answer I can give is that representations of this sort should be sensitive to the explanatory aims of a project. So you might be trying to think about arbitrariness of a convention absent context, in which case you'd want to build a context-free model. Or you might want to think about, the arbitrariness of a convention across real-world cultures, in which case you'd need a data set as your representation. They're not going to be perfect, but you just have to, pick a decent one for whatever project you're engaging in. Okay, challenge 3 has to do with probabilities. Many think that we live in a deterministic world. On this picture, there isn't any real sense in which any convention could have been otherwise. They all had to be the way they are. We all had to be in this scenario that we're in right now. I think when we talk about this challenge, though, recognizing that this measure is representation dependent actually helps. So what you're doing is representing probabilities that different conventions would emerge, however is appropriate, using models or data sets or whatever. And that's the thing you're feeding into the measure. It's not some objective, real-world freestanding probability. Okay. So with that, I will move on to the last bit of the talk and just sort of briefly go through a couple of examples. So I'll apply the measure to cases and talk a little bit about how it can improve cultural explanation in real cases. And there are different things it can do. So I think sometimes just having this conception, conventions come in degrees of arbitrariness, that by itself is useful. Sometimes having specific numbers allows you to compare different conventions to each other. Sometimes you can use numbers to facilitate comparisons between, say, data sets and models, which might be useful if you're in the middle of a debate about the innateness of some cultural trait. So there are different things you can do with this framework. In the paper, I discuss 4 cases. So I talk about gender division of labor and then 3 linguistic cases. So what I'll do is talk about gender division of labor and then one of the linguistic cases, which has to do with basic word order. All right, gender division of labor. So data looking at traditional societies finds that all societies basically divide labor by gender, but there's a lot of variation in those divisions. And there's also variation in how arbitrary the divisions are. So there are some tasks where you can look across cultures and see a lot of stability or regularity. So young infant care is a kind of classic case. It's predominantly performed by women in most cultures because women tend to be female in most cultures, and they tend to have, boobs and ovaries and all the things that make it easier to care for young infants. Other tasks like big game hunting tend to be performed by men who tend to be male and who are not caring for young infants and also tend to have stronger muscles. But then there's a lot of other jobs like rope making, caring for small animals, carrying burdens, which tend to fall to one gender or the other, but there's a lot of arbitrariness as to which. There doesn't seem to be strong pattern as to who ends up caring for small animals. So if you wanted to build a super, super simple model of this, you could use a coordination game. Here's the one I'll use here. This is actually slightly different from what we saw before. It's sometimes called an anti-coordination game because the players get payoffs not for doing the same behavior, but for doing different behaviors. So if you're part of a household or a society, dividing labor means some people taking some jobs, some people taking other jobs, and you all get a benefit from that. And furthermore, I set this up as a scenario where it could be the case, again, that one of the equilibria pays off more than the other. Maybe it has greater benefits because, say, of physical sex differences or some other reason. And here I set it up where it could be the case that one player is more benefited by using this equilibrium than the other, though that won't come into play in this talk. So we can look at this evolutionary model and we can see that as we sort of increase the payoff to that one equilibrium, it becomes less and less likely that the other equilibrium evolves. So this just shows we increase the payoffs to that one equilibrium. And then this shows here's the likelihood you end up at the other one. It goes down and down and down and down. And we can see ourselves scaling from a scenario where there's a lot of entropy, a lot of arbitrariness as to, well, which gender ends up doing a job, to a scenario where there's low entropy, there's less arbitrariness as to which gender does a job. We still have conventions, but you're more in a scenario where there are reasons why one convention versus another might emerge, some payoff reasons. And we can see a kind of slow slide between those different cases. We can run this same analysis on data sets to compare conventionality of these different arenas for division of labor. And I talk about this in my book and some in this paper. The general picture that emerges is informative to debates over the innateness of gender division of labor. So there are these debates over whether you have innate psychological sex differences that mean you're always going to have these patterns. Are they inevitable? Are they going to be stable for these reasons? And as I argue there, thinking about this as a scenario where we're still talking about conventions just in degrees sort of helps cut the knot on this debate a bit. All right. So when we're thinking about language, we might say, well, how effectively, in what ways could we use this picture to think about the emergence of language? And I'll just throw out there, I don't think it's that useful to thinking about semantic meaning, because that's a scenario where it's just too unconstrained. You can't give a good model of all of the equilibria for the emergence of, a word to track your index finger, right? So you can't really get a good model there to compare how conventional or arbitrary different cases are. You can pick out a few cases where you're like, that's less arbitrary than the rest, like the use of the word ma to mean mother in a lot of different cultures, right? But mostly it's too arbitrary. There are other linguistic cases, though, where you have a more kind of constrained cultural evolutionary problem. You have a limited number of equilibria where this is useful. So the example I'll talk about here is like that. It's basic word order. So this refers to the order in a language in which the subject, verb, and object will typically be arrayed. And there are 6 possibilities. It's just the different ways you can arrange these. You can have subject, verb, object, verb, et cetera, et cetera. So if you look across languages, you see a distribution that tends to favor subject first languages. So those have like the most prevalence. And then next you see these kind of verb first languages. And then there are very few object first languages. I wrote here, there's no OSV languages. Someone corrected me and told me that there are like 2, but not very many. Okay. So we have a scenario here where we have this kind of distribution across conventions. We could say if this was entirely arbitrary, if there was no reason to have one or the other, the entropy would be 2.59. That's what we'd expect. The real data, we see lower entropy. So we have a scenario where there's obviously some conventionality. You have different conventions in different cultures, but the distribution suggests there's also maybe some constraints. Could be maybe functional constraints, some payoff reasons, or historical constraints. Maybe there used to be, some main language that had subject first, and then that fed into a lot of other languages. In this one paper, Moritz et al. Give a functional account based on the idea of uniform information density, the idea that you kind of want to spread out information in a sentence. You don't want to drop all the information at once. Other people argue, well, maybe no, there were historical influences at play here. So one way you could proceed is to develop a model that assumes the kind of functional constraints that Moritz et al. Identify as important. And you can look at the arbitrariness of outcomes in that model. You can compare it to the real data sets and see, well, do functional factors explain what we see in the word order case pretty well, or don't they? And that might give you some information in debating what's happening in this kind of scenario. All right, so that's the second example. I'm just going to sum up and then conclude here. First of all, conventions come in degrees of arbitrariness. Just recognizing this improves cultural evolutionary explanation, I think. Second, we can measure that arbitrariness using information theory. And third, this measure can be used in different arguments about the evolution of conventions or cultural traits, including about gender division of labor and language. But I think there are probably a lot of scenarios in which it could be useful. And with that, I will sum up, say thank you.
All right. Thank you very, very much, Cailin, for your talk. I found it very interesting and illuminating about a lot of things about cultural evolution and especially the role of information theory in assessing, in studying these models is particularly interesting to me. I'll have two questions, if I may, and then I'll get questions from the audience. Please, people feel free to write questions in the chat. I have two questions. I think one of them maybe you may have already addressed in the section about the problems or challenges that the models may face. In cases in which you mentioned, some cases may be just too unconstrained, right? The space of variations may be too big. So in those cases, we would have like an infinite entropy, right? For any given Gustavo? Sim, eu posso repetir a pergunta. So I'll just replay the question.
Okay.
Sim, Fábio. Sorry. So apparently we're still mute. Tá ainda sem som? Italo, do you know whether we're still mute? Still mute? Oh, sorry. Agora foi? Are you listening to me? Okay. Okay, good. So, okay. So my question would be whether in some cases in which we have a wide range of possible conventions that may arise, so a wide probability space,
So good. I was going to answer the second question first. Here is my bonus slide on biological conventions. And so most philosophers have defined conventions as unique to human societies because they often have requirements having to do with common knowledge. Like for something to be a convention, I have to know that you're going to do it and you have to know that I'm going to, etc. But there are behavioral traits and other things in the rest of the animal kingdom that you could equally well apply models of cultural evolution to. And a lot of these you could explain via appeal to both chance and functionality. And so you might want to use this kind of measure in thinking in general about how constrained or unconstrained some evolutionary processes. And that would include processes like the evolution of the DNA code. How surprising is it that we end up with that code versus some other code, right? Some other pattern of some other system for passing on biological information. So certainly, I think that applies. Okay, so I don't need the slide anymore, Gustavo. As far as this other question...
Gustavo, pode tirar o slide. Acho que está dando mudo o slide.
Yeah.
Okay, go ahead, sorry.
When really there's an infinity of different possibilities of how far you can go, and there's all those equilibria, and it's infinite, so you have infinite conventionality as well. That's perfectly fine. I don't think the measure is that useful in those cases, though. I think it's most useful in the kind of cases where you can say there's some set number of possible equilibria and then some probabilities of emerging at each one. And that's where it actually does something for you.
Sounds great. Thanks. Do we have questions from the audience? No? Okay. So, about the evolution of languages, in which you mentioned the subject-verb orientations, So, do you believe there is any? I think you mentioned, right, that there could be some explanation about the spreading of information across the sentence, right? But couldn't we also think something along the lines that there is something natural to human cognition? Like, what would the Chomsky say about this? About that maybe our inner grammar that configures this this distribution of probabilities that we actually observe.
Yeah, that's good. So I think that really what you're bringing up is another kind of typical constraint or explanation for why you end up more often at some conventions than others. Sometimes in cultural evolutionary theory, there's like this big divide between different camps. So between the evolutionary game theorists who really focus on payoffs in explaining the emergence of different things, and between cultural attraction theorists who really focus on features of human psychology and explaining why we have different conventions and different cultural outcomes in general. So for this particular framework, it doesn't actually matter. It's perfectly fine, again, to have scenarios where there's a reason some conventions emerge more often, and that reason is that there's something psychologically attractive about them. Maybe it's that we have some universal grammar module. Maybe it's that we just really like bright colors, and so we tend to adopt fashion patterns that have us wearing really bright colors. That, again, can just be one of the things that shapes the probabilities that different conventions might emerge in different models.
Okay, sounds great. Do we have questions? Okay, we have a question from Mitalo. I'll read. Is this account directed to description or prediction of a given conventionality? And can they be used to understand human and non-human behaviors alike?
Yes, I think that it can. I mean, I haven't thought as much about non-human behaviors for this reason that I gave before, is that in thinking about convention, people usually aren't thinking about non-human behaviors. When you apply, this thinking to non-human behaviors, you're talking about a kind of different scenario. So when I've been talking about things could have been otherwise, I'm usually talking about a cultural evolutionary time frame here. Could have been otherwise when people were learning different cultural patterns as a group. When you're looking at the biological world, there are senses in which patterns of behavior could have been otherwise, but it's sort of a deeper, older sense, right? So the mating displays of some bird could have been otherwise, but you have to step back further and say, well, they would have had to then evolve via natural selection on a very long time scale to have been otherwise. So it sort of depends how you want to model these processes. You can certainly do that with a biological group. Say, well, there's a sense in which wolves could have been otherwise. Maybe they had a different hierarchical structure. It's just then an evolutionary counterfactual that you're looking at, and you're looking at a model with a much longer time frame and a different sort of dynamics.
I guess we could say that at any point in that Stephen Jay Gould metaphor of running back the tape of life, of the history of life on Earth, you could rewind it at many different points and get different outcomes from that point on. And so your measurement is always indexed, is always relative to a given point, right?
Yeah, that's right. It has to do with this idea of representation independence. I mean, one thing about evolution and cultural evolution is that you never start at a neutral starting place and then go from there. You always start at some actual place and then move forward. And when you're modeling evolution, people often sort of simplify things by giving neutral starting places, but that's never what you actually have. And so you have to ask, what am I representing? I want to talk about arbitrariness or how things could have gone, but with respect to what starting point, right?
Okay, do we have more questions? tell Italo if someone's typing at the chat? No? So, okay, so I'd like to thank Cailin once again for your talk. It's been great. Thanks for participating, for accepting the invitation and being here. It's been a great talk. I learned a lot, and thanks again.
Well, thank you so much for having me. This was really nice talking with you. If something's gone wrong and folks want to ask a question, please feel free to email me. You can just search my name and philosophy and you'll find my contact and everything, or you can find me on Twitter too. Yeah, thank you.
Okay, thanks. And just on Thursday, we'll continue. We'll resume our